Well, basically it's a welding course, and metalwork in general. There's lots of peripheral issues and skills that come into play. But the basis for it all is we basically teach students how to do oxy-fuel welding, which is just with a torch and filler rod, and it's a fairly slow process, but it does give them a background on what you can do with liquid metal. Then we go into the arc welding, or stick welding as it's sometimes called, and that is a little more difficult process, although it's faster. And then the one that most of the kids start off with, because it's the easiest to get them interested in, is the wire feed welding. You basically have a machine, you pull a trigger and the wire comes out and it welds. And there's no trick to learning how to use both hands, because you have to have the torch and the filler rod in the other hand. There's no trick you have to learn to get it the right temperature and get it to stick and hold it in exactly the right place. Basically, with the wire feed welding practice, students are asked to take a piece of metal. They basically have to start off by welding at the top of the coupon, and then they point the gun right at the very base of the weld they just did, and they overlap it so that there's no valleys. Now in this case there's some valleys, there's some that are a little closer the way you're supposed to put it. I'm teaching them to weld and have it be a useful thing to learn. What I basically do is everything they do is built to improve their skills and build on their previous skills. If there's something that goes wrong, they learn how to fix whatever went wrong, whether they welded the tip to the table or something, whatever it is, we solve that problem, and other students often come and see, well, gee, what's going on? How come it doesn't work? They have to assess the risks on the job and identify the hazards and minimize the risk by taking action to reduce the likelihood that someone's going to get hurt. So I generally have about 12 to 15 students. I have 4 welding booths, and I have a classroom, and I have basically 2 major streams of activity in the class. The other half of the class is spent learning how to work with aluminum. Now, here's an example of an aluminum project that they work on. This is a bottle opener, and they learn about the difference between steel and aluminum. All metal isn't the same. And so they learn by cutting out with a hacksaw and other various hand tools the sharks. The most important thing that they can get from this class is it's very different from any other class they can get, and it's very practical. I think the other thing I would say about it is that this is a course in what I would refer to as applied physics, where we learn the rules of physics that allow us to manipulate metal in its liquid form in ways that you could only talk about it in a science classroom. I find that one of the things that also works in favor of international students is they get to see something done and then they get to do it. They get to basically be shown what to do. It's a hands-on environment, and they're able to do more and learn more through interaction with other students who are also learning something that they've probably not done before. Basically just being able to work with their hands, and they have a lot of time to socialize and while they're working, and they get the opportunity to interact with each other and help each other. When somebody's doing something and it's not quite right, and somebody comes along and says, oh no, this is how you do it. So they demonstrate that interest by going and doing what they know how to do to show somebody else how to do something that they're not quite up on. Just a discovery process for the kids, so it just kind of, it's full of surprises.